We will start the seminar. I think most people know me here. I'm Francis Heylighen. I'm presently the director of the CLEA Apostle. And I'm going to talk about a topic which I consider to be very important. Of course, you would like to believe that all the topics you speak about are important, but this one for me is more important than other talks I have given, in the sense that I think it's a kind of a unification of a very large number of things I have been doing, and not only a unification of things I have been doing, but as I hope to argue, a unification actually potentially for the whole of science. That's why I call it a new ontology for a transdisciplinary unification. So relational agency, it's a recent term. I'm not 100% sure that I will stick to that term. There may be better terms, but I think it captures very well what this new ontology is about. So let me start by saying what is an ontology. Okay, yeah. So starting with the term ontology, which may not be common to everybody. So an ontology originally was a term in philosophy that was speaking about being, ontos, the things that exist. More practically, an ontology is a theory about the fundamental constituents of reality. Whatever worldview you have, you assume that reality is constituted at the basis of something extremely fundamental, the essential, the elements or the building blocks of the things that exist. So any kind of a worldview or metaphysics must have an ontology at its foundations, and often the ontology is implicit. But lately, more and more people are interested in looking explicitly at the ontology, because changing the ontology changes your whole worldview. So there are some classical ontologies. For example, materialism is that the idea that at the bottom everything consists of matter, but then there is idealism that says no, in the end everything consists of ideas. And there are some other versions like social constructivism, where everything after all is a social construction. I'm not going to detail the different ontologies that exist, but go to the ontology which is kind of the most standard, the most default one, the most classical Western ontology. Not that I claim that this is purely Western. You will find this ontology, I'm pretty sure, also in other worldviews, but it's the one that we associated most with the scientific Western worldview. And more specifically by what I have called in my research the Newtonian worldview. The Newtonian worldview, that means the worldview of classical mechanics. And implicitly, since most scientific theories later developed on the basis of this Newtonian worldview, most scientific theories kind of implicitly assume this ontology. And this ontology, why is it so widespread? Because it's simple, because it's concrete, because it's intuitive, and because you can express it very nicely in mathematical ways. So it's what I call the ontology of objects. So we can say that as the whole Western worldview originated really with the ancient Greeks, this too comes from ancient Greek philosophy, and one philosopher there was Parmenides, who had something against change. He was saying that change is an illusion. The only things that exist are eternal, permanent things. Then Plato was looking at these eternal, permanent things as what he called absolute forms, ideas. So the ideas are there eternally. And finally, you had Aristotle, who was a student of Plato, and Aristotle was more practical, was more empirically minded. So he, of course, was not going to deny that objects could change, but he still kept his idea of the absolute essential form by speaking about objects having essential properties. So the essential properties, the essences, are what define the object. So this is the ontology of objects. You have objects that have certain essences that are in there. So let's look at it more concretely. I have chosen here a picture of a brick as kind of a default prototypical object. What is this prototypical object? It's a thing that is distinct. That means we can very clearly see where it begins and where it ends. It's located in space. There is a border around it, and it is inert. It just sits there. It's independent. It's absolute. It just is. It doesn't do anything unless some force moves it. So what these standard objects have as property is they just remain the way they are. They have these essential properties. They remain identical to themselves. They keep these properties. Now, of course, we want to describe change, and not all things are static in the world. So what Aristotle did to solve that problem is that he distinguished between the essential properties, the ones that do not change, and what he called the accidental properties. And with accidental properties, we think about things like the position of that brick or the speed with which you throw it. So you can imagine that that brick is moved in different orientations, but the orientation or the position in which the brick is, it's accidental. It's not essential. It does not define the brick. And if those accidental properties change, that is because something else, namely some outside force, such as gravity, has made the brick move from one position to the other. So the ontology of objects assumes that objects are just there, passive. They do not change on their own. Now, after Aristotle, this ontology has developed further in the direction of materialism, and that is the idea objects are made from an inert substance. So a substance is kind of what carries the object, what shapes the object. The substances can be remodeled or rearranged, but the substances are assumed to be eternal, to be always the same. So a substance is something that just is there. It can't be created, it can't be destroyed, it can't be transformed. And in our modern scientific world, we assume that the fundamental substance of the world is what we call matter. So it's a materialistic worldview. And we assume that matter ultimately consists of particles, which are kind of the smallest objects, the elementary units, the smallest possible objects. So that's the basis of our traditional worldview. What that worldview also entails is what we know as reductionism, which says that, yeah, if everything consists of objects and objects themselves consist of smaller objects, and these smaller objects eventually consist of particles, well, actually that's all there is. If you want to understand something, you look at it as some arrangement or assembly of particles. And if you want to know what happens to that object, you just need to look at what these particles are doing, meaning how they are moving in space and time. And why do they move? Because there are forces. And there we have the essence of the Newtonian worldview. You have massive objects that move under the influence of forces such as gravity. So in such a worldview, yeah, actually you can't really have anything new. Everything exists just out of these bits of matter, which are essentially identical. You maybe rearrange them, but nothing novel can emerge. There can be no evolution, there can be no creativity. And moreover, in the Newtonian worldview, you assume that all these changes, that's to say the forces acting on these objects, they are deterministic. So there is no uncertainty, there is no indeterminacy, there is no freedom. And therefore, there also cannot be something like autonomy, free will, or agency. Objects cannot decide how they will react. They just are passively subjected to these forces. Up to there, the logical structure is consistent. We have all these objects subjected to forces. We can explain lots of things in terms of objects and particles, but then there is one thing which we clearly cannot explain. Namely, if we assume that there are human observers who are looking at those objects and doing things with those objects, then we need to assume that these humans have something that the objects don't have. Namely, that these humans have agency, that they are autonomous, free subjects who can decide, consciously decide what they are going to do. So the brick may be subjective passively to the force of gravity, but I, as a human, can decide whether or not I will throw the brick or put the brick here or there. So then we get that that was the solution of Descartes to that problem, that humans must have something else, something that is not that matter. They must have some kind of a substance that he called mind, which led to the philosophy of mind-matter dualism or mind-body dualism. There is the mind, which is something not material, and then there are the material objects. But immediately that creates a problem which is known as the mind-body problem. If we assume that the body is material and the material particles in the body are subjected to deterministic forces, while the mind has a free will and can interact with the body, then how can that be? That's a contradiction. Either the matter is subjected to deterministic forces, or it's subjected to the free will of the mind. It can't be both. So we have a problem there, which is an unsolvable paradox that lots of philosophers have been lamented about. So for me, this paradox, the only way to solve it is that you really need a different ontology. You should not make that distinction between passive objects and active agential minds that nobody understands quite what they are. So that brings me to a different ontology that is also pretty old. That is the process ontology. And the process ontology, against Parmenides, who said that change is an illusion, process ontology, on the contrary, says change is the most basic thing. So reality is not constituted out of static objects, but out of things that change, out of processes. And that is an old philosophy. It actually dates from before the Socratic philosophers, before Parmenides, and the best known representative in Greek philosophy is Heraclitus, who is famous with his statement that you can never step in the same river twice. A river is not a thing, it's not an object. A river is a flow. Every time you step into the river, it's a different water that you're stepping in, but there is still this river. And we see similar philosophies in Eastern philosophy, for example, in Taoism, where you have this idea of the Tao as a kind of a flow that describes reality. These ideas have been picked up in 20th century philosophy by a number of philosophers like Whitehead, Teilhard de Chardin, and Bergson, but they have never really made much impact on science, and I will later explain why that is. But rather than immediately going into this abstract process philosophy, I first want to come back to something that's even earlier than the pre-Socratic philosophers. And that is animism. Animism is not an official philosophy. It's a way of describing how hunter-gatherers look at the world. It's a concept that was produced by anthropologists who were studying hunter-gatherers and who noticed that they tended to see all the phenomena around them, the plants, the animals, the trees, the clouds, the rivers, as animated. That means they saw them as agents, not as passive objects, but as agents that have some spirit of their own, and therefore the hunter-gatherers live, you might say, in harmony with nature, in the sense that they see themselves as being enmeshed in this network of relationships. So they have relationships with all these natural agents. Now, there are different attitudes towards animism, and the traditional view in anthropology is that, well, animism is just some very primitive, naive view, a pre-scientific view where people attribute supernatural characteristics to these material objects. They kind of tend to think that there is some kind of a spirit living in the tree, and it's all very naive. It's just a projection of the internal theory of mind on those external things. But since recently, since about 20 years, there's a new view developing in anthropology by anthropologists such as Nurit Burt-David, Tim Ingold, and Graham Harvey, who look at animism in a much more pragmatic manner. That's to say, for them, animism is a natural way of adapting to the ecosystem in which you live. That means understanding the ecosystem as indeed a network of agents and in which you, as a human, are just one of the agents among many, and you try to form good, positive relationship with those agents. So this is kind of a little bit of a symbolic depiction of animism. It's the idea that the tree is not just a piece of wood, but it has some kind of a spirit. But we need to understand spirit here as that what animates it, not so much as some supernatural soul-like entity, the way it is depicted in dualistic philosophies, where there is the mind of the tree and there is the material of the tree, and those two are separable. That dualism isn't there in animism. The spirit of the tree is in the tree. It's not something that you can take out of it and that you can see in some kind of a supernatural realm. So if animism is indeed this kind of very natural, intuitive way of relating to the world, then a good question to ask is, why are we no longer animists? And many people nowadays, especially with ecological movement, have kind of lamented that we have lost our connection with nature, that people no longer have this kind of intuitive empathy with trees and with clouds and with rivers. And that, in fact, a lot of our modern problems of scarcity, exhaustion, pollution can be explained by that, because we treat nature no longer as a collection of agents with whom we are interrelated. We are treating it just as a bunch of raw materials, of objects that are just there to be consumed and to be transformed whatever way we see fit. So now I have discovered an extremely interesting author who is not that well known. That's why I want to emphasize that it's worth reading him. Who's called David Abram, who is an anthropologist who has done some field studies in different countries. But yeah, he's not a very traditional scientific anthropologist. He's more kind of what you might call an eco-philosopher. That means he tries to get into the mindset of these people he has been observing, and he himself tries to recreate that kind of animistic consciousness. So he has published 2 books that I both read and which I made lots of different markings, so that it gives you kind of a sign of how much they inspired me. And the titles kind of speak for themselves. So his first book is The Spell of the Sensuous. So he speaks about this sensuous, this embodied sensation of being in the world, in nature, and participating, feeling the wind, feeling the trees, hearing the birds. And the other one he calls them Becoming Animal. Yeah, it's recovering this sensitivity that animals have, where animals walk to the woods and they will notice the slightest changes and noises that we Westerners, when we walk to the woods, we will just ignore. Now, what's also interesting about Abram is that not only he gives you a sense of what this original animistic consciousness was, but he also has a hypothesis of why we lost that. So his hypothesis, I'm not sure it explains everything, but it's definitely worth looking at, is that we lost this consciousness when the invention of alphabetic writing, something that we get from the Hebrews and the Greeks. And why is that? By writing, what you do is you describe something with a word, but the word is disconnected from the thing. The word just stays there. It's in a book. It goes into a library. It loses completely the connection with the context. And a word, by definition, is something static. Words do not change when you open your book. It's still the same words in there. While the tree that the word refers to, the tree will have changed in the meantime. So his idea is that when Plato started thinking in terms of essences, Plato was one of the first philosophers who was really using literate material, was really using texts, that Plato kind of had this idea of eternal forms, essences, by looking at words. And then when you go further and you start expressing these things not only in words, but in mathematical formulas, then you completely cut out the context, which means you make a kind of a static, abstract representation of it that is unchanging. Now, another aspect that is definitely very important also is that since Plato and even more since the hunter-gatherers, we are living in an artificial environment. That means an environment mostly consists of artifacts, artifacts like cups, and cups are passive objects. There is nothing animated or agential in a cup, while in a piece of wood, you may say, okay, it's just a piece of wood. But if you come back 2 months later, that piece of wood may have been eaten by ants, or it may have eroded, or it may have changed color. There is a difference between natural materials that are constantly adapting to circumstances and things like cups and all kinds of artifacts. And if you look at this room here, there's nothing animated in here except people. So this dualistic worldview, it's logical that we make a distinction between material objects that are just there passive, like this table, and animated people, which are all the rest, and there's nothing in between. But if you look outside the window, then you see the trees, and then you see there are other things except objects and people. So I'm not the only person, and Abraham is not the only person who has been thinking in this direction. And I might even say that there is a tendency now in science and philosophy to have a certain renaissance of animism. I will first look at the domain that I know best, the scientific models of agency, and what is now very common are so-called agent-based models. What's an agent-based model? You make a computer simulation of some complex system, could be a market, could be a society, could be an ecosystem. And you do that by defining agents, where agents are entities that follow certain rules and they interact with each other and with the environment to these rules. The agents, of course, are abstractions, but because each agent acts on its own and then interacts with the other, what you see is that the whole tends to develop very complex dynamics. And then we come into the domain that has been called complex adaptive systems. You see that these networks of agents start to self-organize and they develop all kinds of emergent properties. So this is a trend that has been going on, I would say, at least for 30 years in the physical sciences, in the computer sciences, but also in the social sciences and the humanities. There is a certain revival of this, what I would call animistic spirit. So also there we see models of agents in networks, and probably the most famous one is the actor network theory that was developed, among others, by the sociologist Bruno Latour and I don't remember his first name, Albert Caillon. And what they do is they analyze complex social evolutions as an interplay between many different what they call actors, but the actors are not just humans. The actors can be institutions, they can be technologies, they can be even physical resources like uranium. All of these are actors in the sense that their actions will have an effect on how this network develops and what is coming out of it. And this is not really my specialty, but Yasmin here in the audience has worked on that, the idea of the parliament of things. Once you start reasoning in that thing, in this reason, you start to say, well, all these non-human actors, maybe they also have some say, maybe we should give them some rights. And there have, for example, been attempts to give legal rights to rivers. There has been a case like that I know in New Zealand. So that is one part of the influences of this new paradigm. And then there is a paradigm more in the humanities and in the so-called cultural and critical studies that is called posthumanism, which some of the authors are the famous Donna Haraway and Karen Barat. And here the idea is that humanism puts humans central. It's the old idea of Descartes. You have the humans that are rational and that have this mind, and they are different from everything else. They're different from the animals, they're different from technologies, they are unique. So posthumanism says we should no longer take humans as the central part of everything. Humans are just one among many, and the boundaries between what is human and what is not human are often fuzzy. If you think, for example, at technologies that support us, we become like cyborgs. And also, if you think about symbiosis between humans and animals, we can't just say that the human is a separate individual. So what you need to do is to blur these boundaries between humans and the rest of the world and see humans as just one among many agents that are all living symbiotically. So the actor network theory. So all these movements, they're going in the same direction, but at the moment, you can't say that there is really an integrated theory. Each of these have different terminologies, they have different concepts, they have different assumptions, they come from different traditions. Like, for example, very simple idea that you speak about agents in the one and you speak about actors in the other, and a third one might speak about individuals. Obviously, there is a lot of incoherence still. So what I'm trying to propose here is to unify these different approaches by developing a common ontology. So we said that an ontology is a set of building blocks, conceptual building blocks, and we don't want to lose the ability of science to make mathematical models. So we should ideally have building blocks, conceptual building blocks that can also be formalized. That means can be put into mathematical formulas that can be used for computer simulation. So that is why I propose my new ontology, which I call relational agency, and which is an extension of the process ontology. So why do we need an extension of the process ontology? Well, if we look at the process metaphysics in the work of people like Whitehead and Bergson, we see lots of inspiring ideas, but we don't see very clearly, concretely applicable things. So these existing theories, they tend to be quite obscure, complicated, vague, abstract. They also don't have very clear definitions. They say that everything is a process, but then what is a process? Then typical examples are kind of a process of evolution or a process of development, but these are incredibly complex processes where you can't really say where they begin or end. So that makes it very difficult to model. So that is, I think, why these process philosophies have not yet had much impact in science, because you don't know very well how to implement them, how to model them, how to analyze them. So what I propose instead of starting from grand processes without borders, let's start from the equivalent of elementary particles, but we will call these elementary processes. And these processes, these elementary processes, I call reactions. And then these are our building blocks. And then when we need to go to more complex things, then we will just build up more complex things as networks of such reactions. So a little bit for the people maybe with a background in physics, when you go to quantum theory, you see that actually these kind of elementary processes of these elementary reactions are really the basis of everything. Already the traditional quantum mechanics tells you that particles are not objects the way we imagine them. They don't have essential properties, they just are there. Properties of particles, they get their properties through observations. And what's an observation? It's an interaction. So things that do not interact, that do not act in quantum mechanics, they don't really have properties. They don't even have a position in space. In quantum mechanics, you can't say that an electron is located in a particular position. It's only after you make an observation that you can say, it's there, but the moment after the observation, it has again diffused and it's no longer there. So that's already quantum mechanics, which tells you that the properties of objects are not stable, they're not permanent, they're not absolute. If you go to quantum field theory, you come to the conclusion that even the objects themselves are not stable because particles are merely instantiations of fields, and fields are descriptions of potential interactions. So particles in quantum field theory, they are being destroyed, they're being created, they're being transformed. So if people need convincing that elementary processes are more fundamental than particles, I think quantum field theory is a good reason. Also because quantum field theory is the most fundamental theory we have in physics, and it's also the most accurate one, because there are attempts to make more fundamental theories like string theory, but these theories simply don't make any predictions whatsoever, while quantum field theory makes very precise predictions that turn out to be very precisely correct. So let's then start by defining these elementary reactions. And these elementary reactions, I will use a formalism that is so simple that really, I mean, a child could learn it. So I want to have a formalism or a language which is transdisciplinary. It can be applied to all possible cases. The elements of my language are what I call conditions. Sometimes I also use other names like components or molecules, and the reactions that change conditions. So what is a condition? A condition is something that you can distinguish. A condition could be it's light or it's dark. And a reaction then is something that changes that condition. For example, you see here the reaction arrow A. That means something brings A into existence. A appears. I could, for example, say, I'm in the dark and suddenly there is light. A appears. It's kind of like the simplest possible process you could imagine. Something distinguishable emerges, appears. And then, of course, if something appears, it can also disappear. That's the second case here. A followed by an arrow. A goes into emptiness. A disappears. If there was light and suddenly the light is switched off, then the light is gone. Of course, that's not very interesting. If you want to describe networks, you will need to have some relations between conditions. So the next simplest reaction is A leads to B, which means I start in condition A and I go to condition B. Maybe I go from a situation where there is a little bit of light, and then I go to a situation with a lot of light. Or maybe I go from a situation where there is yellow light, and then the light changes into blue. This is still very simple. To get to the full power of the formalism, you need to use a notation that is used in chemistry and in physics to describe elementary reactions. That is the A plus B gives C plus D. A plus B means A and B are both there. A conjunction of A and B, there are two conditions. If these two conditions are there at the same time, then some other conditions will appear. For example, A leads to B could be the condition is dark clouds are gathering. The process is it starts raining. But if I have two conditions, if I have dark clouds are gathering and people are in the street, then it starts to rain and people will seek shelter. So the pluses are just saying that you have two conditions. Now, this level of formalism already allows me to define an elementary agent. An agent is something that makes a process happen. So the agent is the one that performs an action, if you wish, that means that makes the process happen. And I can describe it here in this formalism. I use C as an agent. So A plus C turns into B plus C. That means the C still is there, but the A is transformed into B. The C is a necessary condition to turn the A into a B. So C enables the reaction. In the language of chemistry, C is a catalyst. A catalyst in chemistry is a molecule that makes a reaction happen, but that is not itself affected by the reaction. So this catalyst C can be seen as the agent turning A into B, and the reaction that it performs can be interpreted as what in artificial intelligence is sometimes called a condition action rule. That means the agent is sensitive to a particular condition, namely it's sensitive to the condition A, And whenever it is confronted with condition A, it will perform an action that turns this A into B. Now, one agent can catalyze a reaction turning A into B, but it could also turn C into F, E into F and G together into H, B into E. So generally, an agent will catalyze different reactions. That means an agent can perform different actions, and which action it will perform will depend on the initial conditions. So if there is A, the agent will produce B. If there is B, the agent will produce E. If there is E, the agent will produce F. If there is F and there is also G, then the agent will produce H. So agents have these kind of properties. It's particles, molecules are agents in that sense. Agents will react with certain things, and depending on what kind of agent it is, it will perform certain reactions and not others. So agents have this kind of identity of being able to perform certain actions. Now, if you take all the reactions that an agent can perform together, they form what in physics or mathematics is called a dynamical system. And a dynamical system is the equivalence of a force. That means something that pushes things in a particular direction. It takes the A's, turns them into B's, it takes the B's, turns them into E's, etc. So it is pushing things. A dynamical system is something that pushes things in a certain direction. And we know that dynamical systems typically have attractors. That means that they push things into a region, but they don't push them out of that region. So they kind of accumulate in this attractor region. And we can interpret that very simply, that attractor is like the agent goal. The goal of the agent is to move whatever is there into this region. Now, catalyst agent, in that sense, they play a little bit the role of the objects or the forces in the old ontology. Objects in the sense that they don't change during the reactions. Forces in the sense that they have an effect on the things they react with, but they're not assumed to be eternal. They're not assumed to have these essential properties that remain forever. Agents are just conditions like all the others, which mean that there are certain reactions that destroy agents, that consume agents, that build agents. So agents can play the role of objects and forces in the old ontology, but they have this inbuilt dynamism. They can change into something else. They are not given. You don't need to make this assumption that objects always need to be there. Now, if you reason in terms of natural selection, you see this network of all kinds of reactions, and the reactions are constantly turning things into other things. So what remains after a while? Well, all these things that are turned into other things are no longer there, but some things are not being turned into other things. And so after a while, the ones that will remain are the ones where the available reactions are not turning them into other things. So the existence of things like stable particles, that's an effect of natural selection. In elementary particle physics, you have a zoo of hundreds of different particles, and most of these particles are very unstable. That means they react with some other particle, turn into two new particles, which in turn fall apart or turn into new particles. But from time to time, you could produce a very stable particle like a proton, and then, then the whole universe gets filled up with protons and gets filled up with neutrons. And these protons and neutrons form atoms, and these atoms are also quite stable. So you just let the reactions run. After a while, you stick typically with the more stable ones. There's a natural selection of the most stable one. That explains why, even though the world is at core a big process, this process tends to produce locally stable entities that we call elementary agents. But these elementary agents, like stable particles, they're not very interesting. When we think about agency more in the style of human agency, we're thinking about something that we may call autopoietic agent. So an autopoietic agent to me is a kind of a generalization of a living agent, a living organism. Now, what's the difference between a living agent and one of these physical agents like particles? That is that a living agent is constituted out of processes. So the processes are going on. It's not a stable particle. It's particles that are being transformed into other particles, are being transformed into other particles, but the whole is stable. And here I have kind of thought of the simplest possible instantiation of such an autopoietic agent is an A turns into a B and a B turns into an A. So they are forming each other. But typically, because there is always some losses because of thermodynamics, some of the B's get lost, some of the B's disappear. And to replenish that, you need to have some input of A's. So if you imagine this cycle A, B as a simple living system, the incoming A's is the food and the outgoing B's is the waste, but the two are constantly rebuilding each other. Now, this is, of course, an extremely simple cycle. To make it more realistic, you will need a bit of more sophisticated mathematics, and the mathematics here that turns out to be extremely useful is called chemical organization theory. Chemical is because the inspirations come from chemical reactions, but actually does not speak specifically about chemistry. It speaks about all kinds of reactions. And it is a very simple and elegant mathematical model of this kind of autopoietic system. That means systems that are producing themselves, that are in a constant flow of self-maintenance. And the definition of an organization or a chemical organization is a set of components or conditions and reactions that has two properties: closed, that means the reactions working on the components produce new components, but after a while the new components are the same components that were already there. So the system is closed in the sense that it's only producing things that are already there. And it's also self-maintaining. That means that whatever is consumed by a reaction must be produced again. So whatever disappears, appears again, and nothing new is added. So an organization is something that reproduces all its components. It keeps the process alive. So just to give you a little bit of a graphical depiction, this is a bit of a more complex organization than the one I had. The triangles here are the reactions, R3. The letters here are the components that are being consumed and transformed. I'm not going to go into any details here. I want to give you a much more intuitive example. And this is a very nice kind of thing that you can actually buy over the web, and I'm considering buying what it's called an Ecosphere. It is an aquarium that is completely closed. So it's a glass sphere where nothing enters except light. So there is no air that can escape, there is no water that goes in or goes out. And in that ecosphere, there are a number of organisms that stay alive. And the organisms we will look at here are the shrimps. You see these little red things are shrimps. The green things are algae. And then the third one, which you can't see because they're too small, are bacteria. So how come that these things can stay alive in a completely closed atmosphere? That is because they have reactions that are self-maintaining. They form an autopoietic system. This is a kind of an ecosystem at a very small scale that is producing itself. And what is the production? Well, you need to have an input of light because the plants need energy to grow. So then you will have the shrimps that will consume the algae and also consume the oxygen that's there. And they do that basically to survive. So the shrimps don't change in the process, but they produce waste. They produce carbon dioxide, and they produce a little bit of heat. So if there would just be shrimps, well, after a while, all the algae would be eaten, all the oxygen would be taken up, there would be an accumulation of waste and CO2, the shrimps would die, the whole thing would stop. But at least for the waste, we see the bacteria will take the waste, and they will also use a little bit of oxygen, and they change this waste into nutrients. They also produce a little bit of carbon dioxide. So if there would be just shrimps and bacteria, the system would also not be able to survive. But then we see that the algae, when they get light as an input, they can turn the CO2 and the nutrients, which were produced by the bacteria, into more algae. So the algae multiply themselves through this process. And because there are now more algae, the shrimps can again eat the additional algae, and the whole cycle starts anew. So what you see here is that the system is self-maintaining, and at the same time, it's a process. So it's a self-maintaining process. Everything changes, everything is being consumed, everything is being produced, but the whole survives. Now, this is a commercial thing that you can buy in a shop, but you can also make one yourself, and I have already done that. So what do? You take a big glass jar, you go to a pond, you collect all kinds of things from the ponds, a little bit of dirty water, some mud, some plants, some animals, typically will be snails, insects, maybe tadpoles, some worms. You put it all together, and then you see what happens. And well, initially, it may not go very well. I'm pretty sure that some of your organisms will die because they are not adapted to this particular ecosystem. But after a while, you see that it comes to some equilibrium. That means there will be some species that will survive and that will grow. So they will be fit. That means they will be adapted to this closed ecosystem. And it is a dynamical system. That means things go up and down. There will be fluctuations. Sometimes there will be more algae and sometimes there will be more snails. But if there are more algae and not enough snails, then the snails will have more to eat. They will eat more of the algae, so the number of algae will diminish. The number of snails will increase. If there are too many snails, there would not be enough algae left to feed all the snails, so some of the snails will die. So there will be a kind of a negative feedback that whenever some species grows too much, the feedback will be that it again diminishes, or vice versa. Whenever one diminishes, there will be a feedback so that in the next state it will again grow. So these systems tend to self-organize. Now, we can use the same principle by zooming out to the very largest scale, namely the scale of the whole planet. And if we look at the whole planet is kind of like an ecosphere. It is a closed system. The only thing that enters is light from the sun. The only thing that goes out is heat that is radiated in space. But all the rest is in the planet. And yeah, it has adapted. The planet as a whole is stable. Of course, there are fluctuations. There are occasional droughts. There are sometimes species that get extinguished. There are sometimes new species that arise. But as a whole, the system is stable, is self-maintaining. And if you would write down the reactions, you will see that the reactions are actually, the way I wrote them down, are almost the same as the reactions with the shrimps, except that now I have replaced shrimps specifically by animals in general. I have replaced algae specifically by plants in general. I have replaced bacteria specifically by decomposers, all these kind of animals, bacteria and other that decompose organic stuff. And basically it's the same system. It just at a much larger scale, much more complex. So what you see in there, yes?
Can I ask a question?
Yeah.
Can we go back to this slide? I was just wondering if, like, the role of being an animal or the role of being waste can be exchanged, or, you know, because here we got this idea of animal plants are like things that remain, and waste is somehow like an inanimate thing that participates. So I was wondering if we can like make it a little bit more, maybe more abstract, thinking that the role of what an animal is for us is not the same role that it plays there, because even waste could turn to be as animals as the animal in this view. You see? So you see the point I'm trying to make?
In this particular model,
would be like, okay, but you still start from objects.
No, in this particular model, the animals are agents because animals appear both in the beginning and in the input and in the output of a reaction,
Yeah.
while the waste is not. But I'm pretty sure that if you would make a more detailed model, at some level, waste may be an agent as well. So the agent in my definition is the one that participates in a reaction without being consumed by that reaction. So in this case, the animals are agents, the plants are agents, but the waste is not, because the waste is just, or the oxygen is just being consumed and produced. It does not stay.
Yeah, no, I mean that since you were doing examples of different spatial time-spatial levels, more or less the same structure is kept. So that caught my attention. That then the dynamical roles in the process, being an agent or playing the role of what we understand normally as waste, will be more like a process role than a way of being an object. You see what I mean?
Like,
so it's a little bit more abstract form.
Like an eater and a producer.
Yeah, like we are the waste of another process. Besides being an agent, we are, and that relates to the multi-level thing you were saying. Yeah.
No, but it's a good question, but I'm wondering whether there is a fundamental distinction always between agents and the others. I sometimes call resources. Resources are things that are being transformed into other resources, while agents are the ones that perform the transformation but are not themselves affected by the transformation. But on the other hand, agents also will be transformed by other agents.
But that's always.
But it could be that there are resources that are just resources that do not do anything active. I don't know. Yeah.
I have a question. So, considering that like an idea can exist before the reaction and exist after the reaction, so can an idea also be then an agent?
Yes.
So also then an archetype could be an agent. Like if it's like a kind of governing idea for a culture that persists through time.
That could be, yeah. If there are two criteria for an agent. First, it should persist during the reaction, and second, it should be necessary for the reaction to take place. So if certain things would only happen if the archetype is there and the archetype itself is not affected, then you could say that the archetype is the agent of that process.
Which is proving the agency of God.
Basically, yeah. So like for in a religious culture, like the ultimate agent would be God.
Yeah.
To be the most persistent.
Except that gods have not always existed, that people at some moment invented gods and at other moments have forgotten gods. So yeah, no agents are immortal, and ID agents, I think they're very strongly culture dependent, so they come and they go. But yes, they are agents.
But are you not making a distinction between like individual people and people in general? Because people surely persisted for tens of thousands of years, 300s, but individual human beings don't persist so as long.
Yeah.
Is that important? That it's like there's a difference between like an individual and or a category?
Yes, in my paper I have called it a difference between an agent and an agency, where the agency is a more general term that also includes distributed agents. So that would imply that you need to enter some topology in the system to say like there are agents that are localized like humans, and there are agencies that are distributed such as religions. On the other hand, the agency is still localized in the sense that it is on this planet and not throughout the whole cosmos. So I'm not yet out of this of how to make that distinction in a sharp way.
Why do you choose like equity as patches basically, and like because like another understanding of agency is like autonomy, where there's something that can create itself, determine itself. It's like another view. So why do you?
No, the self-producing things are agents, but agents of a more sophisticated form.
Yeah, but why do you choose the term agencies for something like that? That is because it's like no, you're right?
No, precisely because I want to get rid of this dualism, which says that you have the passive object-like things, and then you have the active agent-like things that have a mind. And what I claim is that the difference between the two is much less big than we think.
Yeah,
That
still there's a difference.
well, there is a difference, but there's a difference between autopoietic. I make a difference between autopoietic agents and what I might call stable or rigid agents. But I think that in many cases, you may look at an agent as stable or rigid at one level of granularity, but if then you look at it at a deeper level, you will see that actually it is a process. I think even this cup, if you would look at the level of quantum fields in between the atoms of this cup, you might find that actually it's some kind of an autopoietic agent. There are models of quantum fields that say that a bond between atoms is actually a continuous exchange of virtual photons. So maybe what these things that we consider as static agents, maybe they are really autopoietic, but at a level where we would never consider them. Yes.
I'm very new to this, so this may be a very strange question, but I try to understand what is new in what I'm seeing. And when you were setting it up, I was like desiring and anticipating on a model in which process seems to be central, and the idea of entity would have kind of disappeared. Now when I see this described, I try to wrap my head around, like I see actually again entities that do processes with each other, just like in chemistry previously. So what is new?
You have a good question. That is why I mean, intuitively we see these things as entities, but that is why I started by calling them conditions. A condition is something that you can distinguish, and a condition is something you can distinguish, and distinction by definition is already a process. So the distinction is in a sense the most basic element, and you can distinguish something, and in our nervous system, basically our brain can only distinguish things that change in some way. Things that do not change, you can't really distinguish. Implicit in the notion of distinguishable is already that it appears at a certain moment, that it's not always there. So the typical examples of conditions are CO2. So we tend to think of CO2 as an entity, but is CO2 an entity? It's a particular state of atoms of carbon and oxygen that is sometimes formed and then again dissolved. And the CO2 that's now in the atmosphere will not be the same CO2 that is tomorrow in the atmosphere. So it's a shorthand, and we tend to use these shorthands and to reify them, to turn them into entities. But actually, they are distinctions. And then the question is which distinctions are stable. And the whole process, the whole idea is if you make a network of reactions, you can start to see which things are more stable, which things are less stable. Nothing is absolutely stable. All of them intrinsically are changes. The basis is change. It's an abstract concept, but it's yeah.
Yeah, I have two questions. One is agent. One question. And second one, I don't know if it's maybe you will cover it in the later on. I think
was thinking about luck. How can luck be defined in this relational agency? What is a lucky agent? Like if I was an agent in this worldview that we're defining, how would luck, randomness, and spontaneity and all these features can be defined with this model?
Yeah, that is also a good question. The way I describe the reactions at the moment, they look deterministic, but there is no, you don't need to make the assumption that there is deterministic. You could, for example, have two reactions. So there are two reactions, A turns into B, and A turns into C. There are different ways to interpret that. You could say part of A turns into B, part of it turns into C, or you could say A needs to make a choice. It either turns into B or it turns into C. If you take statistically as A being a concentration of particles of type A, then maybe you can say 75% of the A's turn into B, 25% of the A's turn into C. But if A is a single particle, it cannot both turn into B and to C. Sometimes it turns into B, sometimes it turns into C. That's what you get in quantum field theory. You have possible reactions, but it's intrinsically indeterministic. You can calculate probabilities generally, but there's typically more than one reaction possible. And statistically, then you can say, yeah, okay, 75% of the A's turn into B, but an individual reaction, it's random.
Is there a way to talk about this, but using like sticking more closely to the kind of like the language of process and relationships rather than talking about particles? Because it's, even though I know you're trying to talk about process, when we keep using this language of particles, it keeps sounding like the old language.
I know, but if I wouldn't use that language, most people probably not even understand what I'm talking about.
But I would be very curious to know what that language sounds like. And I think it's also partly like that our language isn't set up for it.
No,
Some
exactly.
elfish
I have
language.
I think the best term up to now that I found is conditions. So A is a distinguishable condition, but the distinguishable condition turns into another distinguishable condition. So,
Can you describe like within the term?
I'm angry, and then somebody tells me a joke, and suddenly I get very happy. So A was angry, and B was happy. So A turned into B. It's not a particle, it's not a thing. My anger turned into happiness, but anger is not a thing. It's a state, it's a condition.
Which you can measure. That's the point. I think that's the scientific data that is necessary.
Let me
say this.
More fundamental in my ontology, which I haven't discussed at this moment because I wanted to put the emphasis on higher level agencies, is the difference that makes a difference. Something is distinguishable if it's a difference that makes a difference, and making a difference means that if I have an A that doesn't react in anything, that A doesn't exist. For A to make any sense, there should be at least some reaction where it turns into B and some reaction that produces an A. If the difference doesn't make a difference, then it doesn't exist. So everything is only defined by its reactions. And that is, at the most fundamental level, I call it the bootstrapping axiom. That things get their meaning by their relationships with others. Nothing exists on its own. A on its own doesn't have any meaning. A only gets a meaning by participating in these reactions.
How is it different from the empirical maxim of science? Like, if we cannot observe it, then it doesn't exist.
It's a metaphysical view of this. Another version is the Leibniz principle of the identity of the indistinguishables. If there isn't any way in which I can say that A leads to B and A prime leads to B prime, if I say that all A prime leads to B, and there isn't any reaction in which A and A prime behave differently, and I say A and A prime, they're the same. There is no difference that makes a difference. Therefore, A and A prime are one and the same thing. If they participate in exactly the same reaction, they are the same. And that is a problem that many people in philosophy do not understand. They kind of tend to assume that the example I always give is the hard problem of consciousness. You probably have all heard about the famous zombie problem. So you imagine that there is a zombie and the zombie behaves exactly like a normal person, but the zombie does not have consciousness. Well, for me, a zombie must be a real person, because if there is no way in which you can distinguish the zombie from the person, then there is no difference. And then either all people have consciousness or all people are zombies, but there is no sense in postulating something that is indistinguishable. So things exist because they have relationships with other things, which in turn have relationship with other things. That is why it's bootstrapping. There is no bottom level. I will not start from elementary particles, say these particles exist, and everything else is reduced to them. No, I say there is this network of reactions, and whenever something appears in the network of reactions, it's there only because of the network of reactions. If there is no network of reactions, then it doesn't exist.
But does it,
But
sorry,
Not being able to distinguish a zombie can be because you don't have tools yet to remark it. So what do you do then? How do you know that you didn't skip one kind of observation?
Yeah, that can happen, and that's how we learn. That's how we learn.
But you can't
But if
conclude
you
that
say-
zombies
no,
are the same then.
No,
because
but the thought experiment of Chalmers about the zombies is that he says explicitly there is no way you can distinguish. If you take that as an assumption, then you create a meaningless thought experiment.
but I wonder, I have some kind of intuition, some doubt that like even by replacing things by relationships, it's like going back to this, trying to start from this idea of elementary relationships. Yeah, I'm not sure if it's really like a solution to kind of reductionism or not. Maybe it's just reductionism like by another name. Like it's still this idea that you can come back to something elementary, some basic building block that you can then put together to explain the world or
But there's
reduce to
another,
this thing.
there's another aspect about this formalism, which is that if we think in terms of A as particles, and you say, okay, yeah, it's just an elementary particle. A can be anything. It can be as big or as small. It can be me being angry. It can be me being happy. It can be the world having a COVID epidemic versus the COVID epidemic being finished. Nothing says how big or how small these cases are. The only thing is that this is a distinguishable condition that leads to a different distinguishable condition. So it's elementary in the notation. It's not elementary in the sense that of what it represents. It does not claim that what it represents is something elementary. I can use this formalism to speak about COVID, and COVID is something extremely complicated.
But and couldn't it be that a way to express the relational agency model is to express that objects and subjects can switch position? Because if you can show that sometimes an animal is eaten and sometimes he gets eaten, so sometimes he's a subject, sometimes the object, this kind of illustrates the relational agency idea more than just summing up reactions. You know what I mean?
No.
Yeah.
I mean, you simply have the two types of reactions.
Yeah, okay.
You have the reaction human plus cow is human, the human eats the cow plus waste. Here, the cow is being eaten, and then you have cow plus grass, cow plus waste. And here, the cow is the agent.
Yeah, but then I'm interested in the cow becoming the subject and the human object in the same reaction. You know what I mean? There's an example of when you try to plant potatoes in the garden, you think you're the subject and the potato is the object because you choose the potato, but actually you can say that the potato breed chose you because he seduced you to choose him. So he actually is also the subject and you're the object listening to the potato. You see what I mean?
No
It's more of a
problem.
switch
No,
inside of the same
Yeah,
reaction.
no problem. No problem.
Then footsteps after the
Potato
meal.
Yeah.
is driven two humans. Potatoes. So they are both profiting from it. They are both agents.
I would suggest that maybe we move with the discussion to a later part, maybe the ontology gets more clear, for instance.
Yeah, you
Yeah,
said
I don't have that many more slides, but there are a few slides that I would like to show, which to some degree speak about these things. So I think the important concept here is that you can have transitions in levels of complexity. Whenever you have agents, they interact, they tend to adapt to each other until they become mutually adapted. That means they form a network of synergetic relationships, mutually dependent. And that network, when it becomes self-maintaining, it can develop sufficient autonomy so that we will look at it as an agent itself. An agent itself, that means that it will transform certain things into other things without being affected by the transformation, not affected in the sense that it loses its autonomy. So a super agent in this formalism is easy to express as a subnetwork of agents. Yeah, I'm not going to make drawings here. It will become quickly get complicated, but that's an old idea of systems theory. Systems theory says you can zoom in and subdivide your system into a network of subsystems, or you can zoom out and look at your system as just one part of a super system. So you can do this perfectly with this formalism. It's just that at a certain moment you see a certain organization, that means a self-maintaining network of relationships. You draw a boundary around it and you say that's a system. That system I interpret as a super agent, and now I can look at the relation between that super agent and other super agents, and then I can put them together in an even bigger level, and like that I can build up. So some of these examples, these are what we used to call meta-system transitions in the Principia Cybernetica project. The origin of life starting from reaction between molecules, that's what we are now working on in our Autopoietic project, trying to simulate that. Symbiogenesis is also a classic example where you have organs of different types that start living together and form one bigger organism. Multicellularity, cells that live together and start differentiating, performing different roles. So each cell is an agent, but all the cells together, the multicellular organ also form an agent. And of course, the emergence of social systems, organizations from individuals. Yeah, one little more example. The cell can be also understood as an autopoietic agent. A cell is something actually that looks very much like this ecosphere, this glass ball that I showed that has an input of light. What are the agents inside the cell? Well, actually the genes are the ones that produce the enzymes, and the enzymes are the catalysts of the reactions. So in a sense, you could say the genes are the agents inside the cell, but it's not like in the old idea that the genes control the cell. No, the genes are individual agents that form a society, and the different genes need to mutually agree and coordinate their actions. And that, together with the input and output of the cell is constantly adapting to its environment. So genes, inputs and outputs all together form this one super agent that is this very complex symbiotic network.
And what would be the process description of that? Instead of the genes as entities?
Well, genes are catalysts which specifically for genes are very stable because the cell wants to store its information in genes, so the genes are highly protected with DNA, which is difficult to change. But yeah, when you multiply a cell, you need to multiply DNA. When you have a sexual recombination, you do need to change your DNA. So every agent, however stable it is within a certain context, there will be contexts in which that agent is formed or destroyed.
Oh, but I was thinking more. I thought you would say that the processes are done because in the process ontology, I mean radical process ontology, we will expect that the evolutionary process is not for agents. It's an evolutionary pathway of processes evolving. It's not that agents evolve. Processes evolve. They are embodied and observed through the distinctions we make. And this we call them agents, but what evolves for real is the process.
Agents are a kind of local concentrations of processes. So you might see an agent is kind of like a concentrated bunch of processes. That's why I define an agent as a bunch of conditional action units. An agent is really a collection of reactions of processes. An agent is an embodiment of reaction.
I think it's just for clarifying.
Yeah.
So from what you said, so an agent is simply that which persists through the process, right? Like it's this idea of the catalyst.
Yeah.
It's the pattern which remains in a sense, right? All these processes are happening and there's one pattern, there's one thing that's stable, the catalyst, which kind of goes through. It's the thing which in the end undergoes no difference through the process. Everything else undergoes change and difference, and this agent remains the same.
Locally during certain processes, not during other processes.
So why, I think my question is also like, why, in trying to construct a kind of, in some sense, like a process ontology or a relational ontology, relation is another word for difference, right? Which I think we all, I mean, I think all of us here basically agree that it's a super important idea, right? But why, in constructing a process ontology, would you then again put it in the central piece, the thing which doesn't undergo change? If the whole point of the ontology is that difference is the most important thing, why put as the central point exactly the thing which undergoes no difference?
For two reasons. First is to connect with our standard traditional intuitive ontology, which sees objects and agents. The second, because evolution has this principle of natural selection, which means that those that are stable survive. So evolution has a tendency to produce things that are more stable. If that wasn't the case, then all this would be one big chaos, like, let's say, immediately after the Big Bang. Immediately after the Big Bang, there were no agents, there was no stability, there was just one sea of particles reacting with other particles, turning into other particles. Happily, we're no longer in that state. We are in a state where things have coalesced and stabilized, but the stability is always relative. Stability is relative, but without that stability, we wouldn't be here. We wouldn't be able to sit on this bench. We wouldn't be able to talk. So you need to explain why the stability there is. Because, I mean, ontologically, there are two big problems. If you start from an ontology of objects, the problem is to explain change. And in my view, you can't. If you start from invariant things are the fundamental building blocks of the world, you cannot explain change, because if these building blocks are always there, why should they start changing? What causes them to change? If you start from a process ontology, then your problem is to explain stability. We all agree that in the world there is both stability and change. So if you start from the one, you need to explain the other. And it's much easier to explain stability from change than the vice versa. You can't explain change from stability. You can explain stability from change, but stability remains relative. It's not absolute. Yeah.
So the concept of time has a special place in the ontology, because the idea of the essence of the process rests on the concept of time. So it seems like the whole ontology is built on this concept.
I think time, people tend to give time a more fundamental role than it really has. I have been working on mathematical models for the emergence of space-time out of processes. So for me, a process is something more fundamental than time. Time assumes that there is someone with a clock, and that all these clocks are synchronized, and then when the process happens, like A is turned into a B, there is someone who says, that happens at time t2, and that happens at time t1. This is already a very complex construction. At the level of these entities, A turns into B. But where is the clock? Where is the time? Time emerges if you have lots of these things, and then you can see that there are something like the space-time structures in there, and then you can start to look at time maybe as some way of describing these things. But we know from the relativity theory that time also is relative. The time for this particle is not the same as the time for that particle. So the idea of time as an absolute frame, time and space, time and space, that's a Newtonian framework. Like all processes happening in space and time. No, processes happen, and then we look at the arrangement to say, well, we can organize it better by putting these space-time coordinates on them. But space and time are not fundamental. Quantum mechanics is another example where you see that space doesn't actually play any role because things can be entangled that are millions of light years apart.
And then how do you define change?
The change is primitive, so you don't define change. Change is your primitive. That's the ontology. Each ontology needs to have a rudimentary, a primitive element that is not defined. So the process is the fundamental element. Everything else is built out of the process. Even space and time, and I must admit, that's the part that still frustrates me most. It's the first thing I did in my PhD season in physics, is make a construct of space-time out of processes. It worked, except that I needed to make one assumption, which I'm not happy with, and I still haven't found an alternative for that one assumption. Namely, the assumption is that processes don't go back in time, because if they go back in time, then you lose the whole idea of time order, and that's.
Why don't you like it? It's fun.
I don't like.
Opens possibilities.
But like these reactions have certain properties, no? Because like just if you have like often we have like one reaction happening faster than the other reaction, it's a normal time. You only suppose and say you cannot really distinguish one going faster than the other.
No, if you go to the lowest level, you can't. So the kind of formalism that we use at the kinetic and the dynamical level, there you kind of assume that there is a speed of reaction. At the ontological level, I don't want to assume that. Let's say there is a difference between the ontology and the formalism. In the formalism, you may want to add some parameters that make it easier to model, but that are not necessarily fundamental in the ontology. I don't yet know whether these processes should have some quantitative speed parameter in there. That's one way to do it. It's an easy way to do it, but I don't like it because it makes an additional assumption which I can't a priori justify.
I think that there is I mean, sorry, just a short thing, adding to what he was asking, even though we might not have a measurable or kind of scalar version of time, we might, I think it would be reasonable to assume that if we have meta-system transitions, so we got one level, then we get the emergent level, and then out of this, in this emergent level, there is a new emergent level, like from cells to tissues to organisms. We we have 3 levels there, for example, we might expect that the processes that make autopoietic the organism take more time than the processes that make autopoietic the cell. So still, even if we might not have a time scale, we still have an ordering of time, right? Like an order. This takes more time than that.
Yeah.
So-
That would work. That would probably
I
work.
think
Yes.
we at
Yes.
least can kind of make it, order theoretical. And the second thing that maybe hasn't been, and it's following the same point, is that every time you make a model, a representation with a reaction network, you have to make implicitly a choice on the level of this order time scale you're making for the distinctions you want to work with. So now when you say, okay, this A is the COVID model, is the pandemic in a certain city, and this other B is no pandemic in the city, then you are implicitly assuming a time scale where this reaction, in the regular physical ontology, you are implicitly assuming a time scale and a way of making distinctions in time space. But perfectly, you could change this model into a fine-grained model where A now it's an autopoietic system of multiple things that embody like our maybe more mesoscale human daily life view of a pandemic. And then the transition, instead of being seen as A goes to B, it might be like a very long process in this other view, and even seen as a meta-system transition. That in this other level, you look at it as you say, like what's the word, like fundamental reaction, to say. So maybe this choice of level of basic level of representation and timescale induced by that, which is actually the scientific connection, because you make distinctions somehow, and you have to measure them, and for the sake of doing a scientific driven, at least, representation of reality, right? So this part maybe wasn't that explicit in the talk, and maybe has confused some of the attendants because it's very kind of not easy to imagine that A is actually a complex that is autopoietic somehow. It's defined in its own time scale. So this
but it's exactly that confusion that's like why
and then you go fractal.
I would love to hear it expressed in another language, where it's really we stick to this language of process, or because the goal after all is to try to make this unification somehow, right? Like to try to make this, bring all these different ideas together in this new ontology that can be usable, and it's hard to use because it slips into this other kind of thinking. I slip into thinking that these processes are things. It's not like, but also I think what gets lost is a little bit this, what I feel is lost is also this coming back to this animism, like I think that was also such an intriguing part of the talk and of the world of ideas. And I don't feel like this is how our kind of, my instinct is that I don't feel like this is how a hunter-gatherer, nature worshipping cousins and foreparents thought about this.
Definitely not.
Like I think that there's something more about story that's being lost, right? Like I think that the idea of story could be really important, because a story is, after all, like the most persistent thing in this.
I suspect I would like to experiment it. I think Christian Gendeko has been experimenting with it, that you could represent stories as reactions like that.
So I made this human simulation piece a long time ago, Virtual, which was a play based on reaction networks. But it's also the other thing to think about, like if it's about thinking about like what's the most persistent agent in all this. Well, the most persistent agent is also story, because this is all stories. This is all different ways of telling a story about ontology, about how the world works, and so on. So, in a sense, story itself is the most persistent agent, but it's also but it's also process, right? It's persistent, but it's also process. And I think if you're a hunter-gatherer going through the forest, that's how you perceive things. Yeah. You perceive yourself as a story in relationship to other stories. And there's also like an emotional relationship.
The disadvantage of a story is that the story is sequential, and because language is sequential, we can only speak about one thing happening at a time. Or what this can explain is things that happen in parallel. And if you want something like an autopoietic system, you see that lots of things are happening in parallel, and that's what the story cannot catch.
No, but I think with the mythology, it's different. Like with the mythology, you have multiple stories in parallel, and you understand intuitively where you're at in a given mythology or given story.
Yeah, but that's not enough to explain something like how the metabolism of a cell works. I don't think any mythological story will capture all that complexity. But I don't think even our brain can capture it. I think you will really need a computer model to capture that.
But these are stories, though. Anyway, okay.
Yes, they are.
I would like to come back to this complaint that it's which I see it the same way that we are looking at a bunch of objects, yeah, and how this effect is produced, because you say like you would like to hear this language, and I wonder if language is ever able to give you the sound you want to hear. Because whatever we will be doing, we are using language which has nouns, yes, which are the basic protocol that we are using, and then it's translated into this. Okay, let's drop nouns, let's speak verbs and adjectives, adverbs, yes. Let's do that. You will hear processes, yes. But as long as he can put A is chaos, B is changeability of feelings, and C is wind, yes, and you will say, but why are speaking about those objects? Because because they are named and put there, and they are interacting and so on. So I think this is one contributing factor, which is the major one, that we will not get out of objects if we are if we don't change the language by which we are referring to, which is an underlying method for modeling, yes, the natural language. And another contributing factor, which has to do with this particular formalism, is that when you say process ontology or process or relational agency, to me, not necessarily something changing into something is the basic relationship, because
things.
Yeah. But I forget the things changing into, yes. So of course it's I know it's a kernel of your model, yes. But I think relation, process doesn't have to be this changing into, and a lot of agencies of relationships are not this changing thing, but exactly persisting of a relationship, which is the agency.
But persistent relationship for me is a repeated process, a self-maintaining process.
But okay, so
I am friend with you, that assumes that from time to time we talk to each other, we exchange information, we help each other. There is a self-maintaining dual process between you and me.
Fine, but you could think, yes, that the process of the agency of a relationship you could approach in modeling, not by arrows, but let's say lines or whatever, yes, that the existence of this friendship is the agent in your life, in my life, in community and so on. And it's more kind of almost like a gravitational field that acts, yes. And then it would be a different model, I know, but
no, that's perfectly fitting the model.
Is you change the reactions to be the species, and the species to be the reactions. It's actually in the plot, it's the same. But you change the who's who, but it's actually the same.
You mean you can, what I say, you can model with this. This I know, yes, but but the understanding of the relationship as a basic unit.
I think one of the problems with the formalism is that it's so simple and the examples are so intuitive that people immediately assume that but it's too simple. But they don't see how flexible it is.
It is flexible, like A, B, C, and it's maximum flexibility, because anything can be it's a maximum. Except, I'm now speaking about this, the ontology of the turning into, yes, that there could be an ontology of, just different types of relationship that turning into. This is
when you define agents, why not defining, getting rid of agent and defining it as shared agencies? Because at the beginning you said everything is about relationships, and this ontology is based on relationships. So if we have For example, you have that formula, human plus cow, human gives something else on that first line. So yeah, that one. So probably I'm thinking of well, how much of the human is a cow and how much of the cow is inside the human already as a potentiality. So could it be, I suggest, kind of defining as some form of every person and every entity or thing is a shared agency already. So kind of like a precondition defining that everything has.
What do you define as a shared agency?
Meaning that, well, you are by nature, you are of a relationship nature rather than an agent. Because when you say an agent has a boundary and has its own internal dynamics based on complex elective systems. Like
Yeah, but it also has the relationship. That's why the whole thing is a network. The whole thing is a network. There are no independent things in there. There are no things that are not network. I mean, if I would do it. If now I would draw one here, that's not possible. Everything needs to be part of the one big network. There are no agents that do not interact with other agents. Because if they don't interact, they're not there. They don't act. They don't exist.
So it's like a field of agencies that is being shared.
You could call it like that, a field of agencies, yes. Actually, the field metaphor is quite nice because fields are typically seen as these kind of arrows that are interconnected and point in all kind of directions. And what the field does is it creates a flow, it makes things move. It's another way. I mean, there are different metaphors to try to explain this. What I have been emphasizing here is agency, relationality. The basis is process. Why do I define agency? Because of these new approaches I spoke about, multi-agent systems and actor network theory, where people are more and more starting to think in terms of agencies. And why relational? Yeah, because the agents do not exist on their own. The whole point of the exercise is that everything is one big network of interactions in which locally you can distinguish agencies, but they are only locally autonomous or stable. They're still part of this larger whole, and this larger whole will change them. But you need local stability, because otherwise you have a world that is like, as I said, just after the Big Bang, a world that is pure chaos, pure change. You need to explain why this table is stable, and why this thing is stable, and why I'm less stable on the table, but still, I will still be there when you talk to me tomorrow. You need to explain that. So you need to explain why in this chaos, this field of actions and interactions, there are islands of stability, which are relative. I mean, they are like floating islands. They don't stay in the same place, but they're kind of islands where you know if you go on that island, you won't sink to the floor. There's stability there.
What if you didn't need to explain it? I'm being a little bit like provocative, but what if we for a second we just accept that we don't need to explain why the table is persistent and stable, so for a time. Like
because
it
I mean,
seems
as
to
an
be kind of getting in the way. Like this is like I don't really care about it. You don't really care about it. We're talking to some other people who still believe in Newtonian mechanics, and somehow we want to convince them of our way of thinking. But like, what if we just left them to their own devices for a while and just got on with thinking about process without trying to convince
but the problem
prove
is
that the table exists?
the problem is
no, but as a mystic or as an artist, you might take that attitude, but as somebody who wants to change the world, who wants to be pragmatic, who wants to develop technologies, who wants to do science, you need to look at stable things. You need to make sure that the vaccine you have developed against COVID will still work in 5 hours from now. If it's just a process and the vaccine changes every minute, then you can't solve COVID.
But I think stability is not about not changing, but about not having an effect on something. And when you look at the table, it's not stable always, because if you fall over a table, it has had an effect on you. So it's not always a stable thing. So it depends how do you define stability. If something has, even an object has an effect on you, it has agency because it changes your life, no?
Yeah.
So So some of these agents are static. There are theories that say like vibrant matter, that all objects have agency as well, because they can have effect on other objects or agents. You see what I mean?
I'm wondering about like more pragmatic, or let's say, yeah, with regard to what science does, how science discovers things. And I'm thinking about like what is the epistemic value of this ontology as opposed to Newtonian classical ontology? Because at the end of the day, we're collecting data, and the ontology we have, the metadata we have there, basically, you could call it like stable processes or stable conditions. But at the end of the day, it goes back to the same way of viewing the world, which is just some entities. You could call it process. I mean, it's just like things like a change of terminology, but at the end of the day, we're doing the same. We're gonna go back to doing the same thing.
No.
Can I complement the question a little bit? Because it's very much related to your question, and I think you can answer both at the same time, which is where will you position this? Because it's philosophical, say, standpoint, but also it's kind of linking to science. So where would you put it in the philosophy of science, let's say, traditional groups? Like,
I'm not sure I want to put it in the philosophy of science, but what I want to say, it's, as I said it here, it's an extension of the Newtonian worldview, which means it does not say Newton was wrong, objects don't exist. It says, in some cases, it is useful to think in terms of objects following the laws of motion of Newton. But if you want to go deeper, and especially if you want to look at processes like I say here, life, mind, society, culture, then the thinking in terms of objects is not useful. So it's like in classical scientific revolutions like relativity theory or quantum mechanics, relativity theory did not negate Newtonian mechanics. It says Newtonian mechanics is a limit case for low speeds of light. Or quantum mechanics will not say Newtonian mechanics is incorrect. Newtonian mechanics will say Newtonian mechanics is an approximation for macroscopic objects. So in that sense, Newtonian mechanics and all the existing theories of science are not negated by this, but they are seen as limit cases for more specific situations where the processes are very simple and you don't have to take into account all these complex autopoietic self-maintaining interactions. So what this does is expand the field of things you can describe to things like life, mind, consciousness, etc., but without giving up the old stuff which we know works. It's just that we now don't take it as literally anymore. We're not going to say that atoms are like billiard balls. We know that. But still, sometimes it can be useful to think of an atom like a billiard ball.
You mentioned mathematical modeling at the very beginning of your talk. So to make it really concrete, I'd be interested in seeing a very simple application. You mentioned I want to do research on humans or on societies, and I'm going to do that using mathematical models. So in what way will I do it different than I did it before because of this ontology?
Well, we have a number of mathematical models like that.
Two people in the audience are doing that.
Yeah.
In the online audience. The last two are starting to do that. But I would like to compliment on your answer, Francis, because the title I think is extremely clear on that. But maybe since it's the title, maybe it's also kind of overseen. Is the ontology for transdisciplinary? Do you call it transdisciplinary in science? I think. But the word transdisciplinary, yeah. So the point is that in traditional science, the act of identifying the objects is kind of immediate. You want to study in ecology, what do you have? Species, resources. It's kind of like the ontology that we come equipped with from natural language is already giving us the entities we want to observe, and it's all kind of culturally, constructed. It's easy to say, we're going to study these things that already have a name and so on. When it comes to transdisciplinary research, the problem of identifying the objects, it's already like what are your guys? What are the guys that you will be studying with? That's already a problem. And that's why the traditional approaches in physics and so on might fall short. Because you don't want to study the entities themselves. You want to study these meta guys that seem to be more representative of the phenomenon than the entities that are composing this phenomenon. Like in COVID, me being sick, neighbor of someone not sick, it's like it's not the phenomenon of COVID. But that's how in agent-based models, and you saw like all the literature during the pandemic was doing that, was focusing on the basic entities, doing models and see how this thing works. But another perspective is to look at the whole of the situation, of course composed by parts, but looking at the potential states of this global situation. And there is something called top-down interactions that maybe Francis, you can explain better than me, which is also interesting, but because when you don't know what these big guys, these major transition guys are, and then you identify them, you can see that this meta systems are also making influences on the individuals. And that's like in social science, it's very common. Maybe you, Marta, can give examples of top-down
how is this
influences.
different than just a very complex system? So using, like, if you look at standard psychological research, they use also unobservable objects like intelligence or personality. And then you could just build it up until it becomes very complex, like gigantic society with multiple people interacting in very complex ways, also with objects.
Yeah, and the point is that this provides, I mean, in my view, I mean, Francis, you can say, no, she's wrong, but in my view, this provides a conceptual framework to start understanding the levels of representation. And it's not just from scratch, and then I look at statistical macro properties, and then I say, this is happening. Because this is the typical complex systems thinking, that the guys approach any big question from the model, and there is no conceptual framework to think about the different levels that start appearing and the meta level interactions that can happen. So if you start from this perspective, you have like a set of principles that you want to look at before saying, this is the phenomenon. You want to build the story of the complex system level by level, let's say. And I think this is an important gain on it. And particularly, we have been doing models or trying to conceptualize better notions that are typically interdisciplinary, like sustainability or resilience or concepts of notions of that kind, that kind of when you look from the very bottom part of the system, you kind of fall short of explaining. But if you look at these different layers,
I would like to add something. I made my PhD in physics on the structure of physical models, and I came to the conclusion, that's my analysis of the Newtonian framework, that there are always a number of ontological elements that are kind of assumed. You first assume that there are your objects, which in your case might be people or organizations. These objects have properties. These properties can take on different values. These different values define states. These different states define a state space. And then you assume some kind of a dynamics of how the properties change over time under the influence of different forces. And like that, you build layer on top of layer, and then you get typically a very complicated model. But actually, all your ontological assumptions are already fixed in the model. So you can't afterwards, you can maybe fine-tune a little bit by changing this parameter or that, but you can no longer change the model while you're working on it. While with this kind of modeling, I just add a few reactions and the whole model changes, but not in a way that you lose what you had. You can put it in your simulation and you see that if I add 2 or 3 reactions or I remove 2 or 3 reactions, well, the dynamics changes. But you don't have to throw away everything. You don't have to start from scratch. That's what makes it so easy. You add a few things, you take away a few things, and each time you have a working model, and some of those will be better, some of those will be worse, but you don't need to start from scratch.
With this macro level relationship, the emergence, does it also we also define it as a process because it seems to be happening in parallel, or one is like is dependent, but supervenience relationship between the two. So one supervenes on the other. So is this also a process?
I don't like this notion of supervenient. I speak unashamedly about emergence when I look at a whole that has properties that are not properties of the part. And how do you get wholes? It's very simple. Suppose that here I have some more or less close structure. Around it, I look at it as a whole, then of course there are still things that go in and go out because nothing is isolated. And now I can look at this as a whole, and this as a whole will have properties because what comes in here undergoes all kinds of non-linear interactions. Whatever comes out here, it's not what went in here, it's not one of the things in there, it's the whole self-maintaining thing that has produced this output. And yeah, so I say this thing as a whole reacts in a different way than any of its components. It has emergent properties. But in this case, I can say, well, I'll see it as a black box. I don't need to know all these details inside. To simplify my model, I will just look at what comes in and what goes out. In other cases, I might want to look inside and look at all these things and then notice that actually there are still small ones in there. And then I can make my model as detailed or as coarse as I want. That's what you want of models. They're always simplifications, but the question is to leave out the things that you find less important and to get in the things that are most important. So, and then by experimenting with this language, I think it's much easier to make good models. Yeah.
I was wondering if you could elaborate a little bit more how the mind fits into this model, or what the explanatory power of this model is, particularly with respect to the mind.
And actually, the mind is, you might say, the most obvious application of it. I started by saying that Descartes had this problem of there is matter that follows these deterministic laws, Newtonian laws, and there is a mind that can think of its own, that is free, that has free will, that has rationality. What I say is agency is something that's in between the passive object and the free willing mind. And depending on how much agency there is, it will have more of these properties that we associate with mind, intelligence, emotions, memories, values, goals. And agency, as I have developed it in a couple of other papers, and what we are doing now in our project is, as this network, this autopoietic network becomes what we call more resilient, which means more adaptive, more able to deal with more different outside situations, it becomes smarter, it becomes more autonomous, it becomes less dependent on the external conditions. And at a certain moment, you will say it has a mind. And for me, there is no such thing as mind or no mind. It's a continuum. I call it agency, and there is low levels of agency. The particle has a very low level of agency, and my brain has a very high level of agency. And in between, you have bacteria and trees and rocks, and they all have agency, which means they all have some degree of mind.
But does also imply they have some degree of consciousness, or what does consciousness?
Consciousness, I interpret as sensation. This thing is sensitive because if there is an input, it changes. So, the example I gave with the A and the B, A produces B, B produces A. Now suppose that there is also a reaction A plus C gives D. The moment I bring D into the system, D plus as C into the system, C plus A will produce D, which means there will be less A available. So the system feels, it senses that something is not the way it should be. What is the way it should be? Self-maintenance. natural selection leads to systems that are self-maintaining. The moment something happens that affects their self-maintenance, they sense it, they feel it, and they will react to it. That's the autopoiesis, compensation of perturbations. You become sensitive to perturbations, and then you act to compensate the perturbation.
So self is consciousness. Then.
It's a consciousness, but at a very, very limited level, at a very primitive level. Yes, the bacterium is conscious of the fact that it is moving in an environment where there is toxins, because it has certain rules that says that if toxin concentration increases, then it should change direction and move in a different direction. So the bacteria is sensitive to toxins. You can say it feels that there are toxins and it performs the action to move away from these toxins. So it's a kind of a consciousness, if you want to call it like that. So some people call this panpsychism, that even elementary particles have this sensation. Yes, if you want to call it like that. I don't object, but I just wouldn't use the term to call it a mind. No. It's a question of more of taste in terminology than in conceptual difference. For me, mind is a continuum from elementary particles to the human brain and up.
Connecting to that, I don't know if you have seen the work of Lenin on this notion of intelligence as a, and it's very similar to what you have you seen that? Because we kind of have gotten.
I have read a couple of papers of Levin, and he has a very similar.
I was reviewed for an article on that.
Yeah,
so I will send it to you.
Michael Levin has very similar ideas.
Collective intelligence. Also, he speaks of this. Well, like typical relativity theory-like inspired cone of intelligence that is like the span you can reach with your consciousness in the process-like sense.
Yeah.
And then he says, okay, we are at this level now, humans, and then a group of humans has a higher cone, so a higher intelligence, and then he put robots and other things and planets and that. So he goes all the way up to.
Yeah, I think his model is simple and nice, but a little bit too simplistic. He kind of imagined that if this is me, this is space, and this is time, then I'm aware of a certain region in space-time. That's my memory of what has happened.
Yeah.
This is my idea of what's going on in other places in the universe, and this is my anticipation of what might happen. And then he says, for a human, that will be big. But for, let's say, a dog, it will be small, and for a bacterium, it will be tiny. So he says it's the wider the range is, the higher your consciousness or your agency. It's one way to do it.
Our time is up, so
Will I share the article?
we'll close here and continue.
Are there any questions from the audience?
Yeah, we didn't even ask because there were so many questions in the room, and now it's the time is up. So do you want to extend it to like a bit? Or?
For me, it can be extended a bit.
Yeah. So if there are any questions from the audience online, because soon we will be moving, to a more informal part of the meeting and leaving this room. So. I think we can take one or two questions from the online audience, if there's any question there, guys. Look, Joris is saying one. Anyone?
I have perhaps a small comment only. Is it clear? Can everybody hear me? Oh, yeah. No, just to comment a little bit. First of all, very interesting talk, Francis. I enjoyed a lot. And I would like to comment a little bit on the observation that Orion and Martha were making also. Why starting from this kind of ontology? It could be that we will have some more surprises, of course, if science develops more, and there could be some hints already. And the comment I want to make is a little story that Feynman once said when in the beginning of the quantum computer ID, there was then a whole theory in computer science, the Turing machine, a kind of a fundamental theory. The Turing machine would be the fundamental entity of computation. And still many computer scientists work with this as a fundamental entity of computation. And then the quantum computer came, and Feynman once said, yeah, the problem with Turing is that he didn't know what paper was, what a strip of paper was, you see. And so the Turing machine, you need a strip of paper. You need something of the material world. And so a quantum computer doesn't work with strips of paper. Things are not on paper anymore. And I think we will stumble at a certain moment that might, when I hear Orion say, why not start with stories? Of course, you can see as a scientist, it's very difficult to have a grasp on a story. But we might stumble on the foundations, I think, where even writing on a blackboard or what we can do mathematically will be too limited to really go deep into reality. Because if you write on a blackboard, A, B, C, it's of course something specific you do. A gives B, B gives C. You cannot do what eventually a quantum computer could do, on a blackboard. So just my comment would be that in an amazing way, we might be repeating parochial things in some way, like the old reductionists, in the time of and not be completely aware of it. That is a little bit what could be the future of and then of course we will have to change again. We will have to adapt ourselves again to new findings and stuff like that. And I think that is a little bit what sometimes is felt also. Yeah, processes, but processes, okay, you can make it say it's perhaps not in time, but there is something also that limits ourselves to being on a blackboard, to imagine with our material mind what can happen. So even there, I think there are some limitations if you really go to the depth of what an ontology is. I don't know what the limitations are. There are some hints here and there, I think.
So does it mean that every century or every generation or every time that we kind of advance in our understanding of reality, we remake the reductionism? It's kind of like the renewed reductionism. Does it?
I think every form of knowledge is a simplification of reality. Every model is a reduction. You should be aware that it is a reduction. As long as you're aware of that, I don't think there's much danger in the moment you start taking your model for reality, that's when it becomes dangerous, because then you are a reductionist. Then you think that what your model says is what the real world is. Well, a model is something that helps you to predict and to understand certain things. And if it turns out that something it doesn't predict or doesn't understand that well, then you may change your model, but you should not take the model for reality. Model is, by definition, a simplification. That means a reduction.
Isn't reductionism is, to me, means that you, it's a worldview where you fail to take the relationships into account. So you think that somehow the world can be explained by things, but not really their relationships or their interactions.
The standard reductionism is like that, but I think the reductionism that Dirk and Shima are talking about is the fact that you reduce things to some marks on a blackboard, and of course, reality is more complex than those ABCs with arrows. Of course, it is more complex. Of course, it is a simplification. It's a simplification which no longer assumes objects. It assumes processes and interrelationship. But still, when I try to represent it on the blackboard, it's a simplification that's unavoidable. the only way to communicate the whole of reality is to experience the whole of reality. I can't transfer the whole of reality to you, to your mind. I have to put it into language and into symbols. That is, of course, a simplification.
The reductionist framework can also take into account complex interactions, no? You just start from the most basic particles, and then you can make it very complex.
Yeah, that is the advantage of this thing. It's what I would call an open-ended model. It's a model where you can add and change things as much as you want. You don't have to make certain assumptions that there are these particles and they have these properties and no other properties, and they obey these laws and no other laws. That's reductionism. You make this ontological assumption and they absolutely can't be changed. While here, the only assumption that I make is there are conditions that sometimes transform into other conditions. And if these transformations appear in a certain pattern, and I see that there is stability and there is self-maintenance, and then I can start saying non-trivial things about them. But I don't say what those ABCs are and what the arrows precisely are. I don't say when they happen or how long they happened. That makes it open-ended, that makes it flexible.
But yeah.
Time to finish.
Is there a question on the chat?
No, it was goodbye.
But then, we can talk about it later.
Yeah, so we move it to the bar, okay? And thank you, everybody. Thank you, everybody online. I'm closing the Zoom, okay?